Hi students, today we're going to do section 8.4, which is variation and problem solving. We're going to cover 4 basic types of variation. The first and most straightforward is direct variation, where we have 2 variables and y is going to vary directly as x. What that means is that when x increases, y will increase. When x decreases, y will decrease. So they move together, essentially. The equation that represents this is going to be y equals k times x, where k is the constant of variation. The constant of variation is going to be a fixed value that relates the 2 variables, okay? For inverse variation, y varies inversely as x varies, meaning they move in opposite directions. So if x increases, y decreases. The formula for that is going to be y equals k over x. And here, k again is a constant of variation, so it's going to be some fixed value. Then we have joint variation, where y is going to vary directly with the product of variables. So it's direct variation, but we have multiple quantities that get multiplied together to y is going to vary. So in joint variation, y is going to equal our constant times the product of more than one variable. So in this case, x times z. Finally, we have combined variation. That's going to be some combination of inverse, direct, and joint variation. The formula for this will change depending on your situation. For example, you might have that y varies directly with the square of z and inversely with x. And in that case, we would get this equation, y equals k times z squared over x. When we are given the type of variation and some initial conditions, so this means a value of x and y, we can determine the constant of variation and then create an equation that will tell us how x and y change in relation to each other. Let's do an example of each of these 4 types of variation. So direct variation, y varies directly as x. Sometimes we say that y is just a multiple of x. For example, let's say the number of slices you order varies directly with your total bill. And here you are, you're at a pizza shop and you're just ordering pizzas or slices of pizza. Now our initial conditions say that if we order 3 slices, it's going to cost us $6. So now we want to find an equation that is going to give us the cost as a function of the number of slices that we order. Okay, we know that this is direct variation because you know that the more slices you order, the more you're going to have to pay, right? But it also tells us these 2 quantities vary directly. So we know the equation we're going to have to use is going to be y equals k times x. We're going to plug in our initial conditions first to determine what our constant of variation is. Okay, so we know that when y is 6, x is 3. So we'll plug those guys in and then we can solve for k to get that k equals 2. We get that k equals 2. We get that k equals 2, and now we can plug that back into our original equation to get an equation that relates our quantities x and y. For any value of x, we can now calculate the value of y. So here in pink, I've circled the that relates our x and y, right? So that's direct variation. It's the most straightforward. Let's take a look at inverse variation. In inverse variation, y varies inversely as x. meaning if X gets bigger, Y gets smaller, and vice versa. Some kinds of things that vary inversely are going to be speed and time, right? Because the faster you go, the less time it takes to get somewhere. And things like pressure and volume. The more pressure that is applied, the smaller the volume is going to be. So in inverse variation, y equals our constant divided by x. Let's do an example here. Let's say you own a restaurant and the profit you earn varies inversely with the wage you pay your workers, meaning the more you pay your workers, the less money you're going to make. If your profit is $100 when you pay your workers a wage of $20 an hour, find an equation that relates the profit and wage. And then once you have that equation, try to determine what your profit would be if the wage was $25. Okay. So here we know that our profit and wage vary inversely. And we're going to use this formula y equals k over x. And we know that we have our initial conditions. So our profit y is going to be $100 when we give them a wage of $20. So first we'll figure out what our constant of variation is by solving this equation, 100 equals k over 20. And we get that k is constant. So now we go back to our equation that relates profit and wage, and we find that that equation is y equals 2,000 over x. So that's the equation we were looking for. And we need that equation so that we can do further calculations to try to see what wages we would need to pay to reach target profits, or to see what profits we get, in this case, when our wage is $25. So if we want to know the profit when our wage is $25, we're going to use our formula y equals 2,000 over x and just plug in 25 for x. All right, so let's say that the wage is $25. Then we can see that y is 2,000 over 25, so we know that y is $80. So what this tells us is that we make $100 if we pay a wage of $20 an hour, but we only make $80 if we pay a wage of $25 an hour. Okay. Finding formulas like this is obviously very helpful because you certainly don't want to pay a wage that is going to cause you to have zero profit, but you do want to pay a competitive enough wage that you can hire employees. Take note here that there were two things that the question was asking us for. One was the equation that relates our profit and wage. That's this y equals 2,000 over x, right? You have to set up this equation after solving for k, right? Just knowing the constant isn't enough. We have to know the constant and plug it in to our relationship here so that we have the equation that relates our quantities. Then this question also asked us to use our equation to determine something, and we did that as well. Now let's take a look at joint variation. Joint variation, y varies directly with the product of multiple variables. So some things that vary jointly are going to be like area varies jointly with the length and the width of a rectangle. Okay. So let's look at an example. If we have a piece of property and the dimensions of this property are 484 feet wide and 200 feet long, and then we are told that this property has an area of 20 acres, let's find the equation that gives the area as a function of length and width. Okay. Well, we know that these things are going to vary directly, right? The wider and longer our piece of property is, the more area it's going to have. So we know that the area in acres varies directly with these two quantities. So that's called joint variation. And we're going to use our joint variation formula. We're going to plug in our initial conditions where 20 acres is some constant times the width times the length, and then solve for that constant. So now our constant is 1 over 4,840. We take that constant and plug it back into our original relationship, and now we've created an equation that relates our three quantities. This equation will tell us basically how many acres we have if we know the length and width in feet. And interestingly enough, it turns out that 4,840 square feet is 1 acre. Sorry, yards. It's all supposed to be yards, but you can just ignore those units in this example. Now let's go on to combined variation. Combined variation is just any combination of inverse, direct, and joint variation. So there's no fixed formula for this. This one, you're going to have to come up with your own formula. So in our example, they say that y varies directly as x and inversely with the cube of x. So we're going to come up with this formula. Y is going to vary, directly with z. So z is going to be in the numerator because we're going to multiply by z, but inversely with the cube of x. So we're going to divide by the cube of x. And you always have that constant of variation in there. So we've just created an equation where y varies directly with z and inversely with the cube of x. The initial conditions say that if y is 15, when z is 5 and x is 3, then we can find the constant of variation and then find the equation that relates x, y, and z. So we've got our initial conditions for x, y, and z, and I'll plug them all into our formula. Then we'll solve for k, and we find that k is equal to 81. Now we can come back to our equation that relates our three quantities. Y equals 81 times z over x to the third. See how I've highlighted in pink that k is 81? That's because the question specifically asked us to find the constant of variation. So k equaling 81 is part of our answer here. And now the equation that relates all three things is that y equals 81 times z over x to the third. So we also need to include that equation in our answer. Take a look at how we solved all these problems and make sure you understand the steps, and then get started on your homework